Hello, travelers of the unknown. My name is Arthinox, and this is Cloaked Mysteries. It's been a while since we last explored a large-scale natural catastrophe on a cosmic level here on the channel. Still, we know that this kind of subject sparks curiosity, fear, and fascination in equal measure. After all, imagining the end of the world has always been one of humanity's deepest obsessions. But today, I want you to look at this scenario from a different angle. Instead of focusing on Earth, the Moon, or even the Sun, we're shifting our attention to something far greater, far more violent, and absolutely unpredictable. Today, we're going to play with the forces of the universe. We're going to provoke the unthinkable. We're going to imagine what would happen if Jupiter, the largest planet in the solar system, collided directly with Saturn, the second largest gas giant. I'm not talking about just any collision, I'm talking about an event powerful enough to rewrite the history of the solar system itself. If that sparked your curiosity, then take a deep breath because the journey begins now. At first glance, imagining planets colliding might sound like something straight out of a science fiction movie. But in the real universe, these collisions are far more common than we tend to think, especially in young stellar systems. When stars and planets are still forming, chaos reigns. Celestial bodies of different sizes compete for space, orbits intersect, and violent impacts occur with frightening frequency. There is strong scientific evidence that both Earth and Mars survived this turbulent phase during their cosmic youth. They endured intense bombardments and still managed to stabilize over time. Our solar system, however, is ancient and relatively stable. The orbits are well-defined, and planetary collisions have become extremely unlikely. Even if a rogue planet were to enter the solar system, it would most likely be captured into a distant orbit, never coming close to the Sun or the gas giants. And despite all our technological advances, we still haven't been able to directly observe a planetary collision in another stellar system. Everything we know comes from mathematical models and simulations. Completely destroying a planet is not a simple task. Contrary to what many people imagine, most collisions do not result in total annihilation. According to mathematical models developed by astronomers, only extremely heated impacts at absurdly high speeds are capable of completely pulverizing a planet. In most cases, a large portion of the planet's mass remains intact after the impact. But that doesn't mean the event goes unnoticed. Quite the opposite. A collision of this magnitude releases unimaginable amounts of energy capable of drastically altering the surrounding environment. When we're talking about two gas giants like Jupiter and Saturn, the consequences become even more complex, since both possess colossal atmospheres and extremely dense cores. To better understand this, we need to analyze different possible scenarios, varying both the angle and the speed of the impact. Let's begin with the seemingly less dramatic scenario. Imagine that some external event pushes Saturn out of its orbit, sending it on a path toward Jupiter. In this first case, the two planets don't collide directly. They merely pass extremely close to one another, close enough for their massive atmospheres to lightly brush against each other. Even without a direct impact, the consequences would be enormous. The gravitational interaction between the two would increase dramatically, triggering colossal storms on both planets. As Saturn draws nearer, Jupiter begins to exert its dominant gravity, ripping vast amounts of Saturn's atmosphere away. Part of Saturn's gaseous material would be siphoned off and absorbed by Jupiter, while the weaker planet would lose mass irreversibly. In this gravitational duel, Jupiter would emerge as the clear victor. With the gravitational disturbance underway, Saturn would suffer a massive loss of its atmosphere. To a distant observer, it would look as though a luminous veil of gas were stretching from the smaller planet toward the larger one. Saturn's famous rings would not survive this event. Composed mostly of ice and debris, they would be pulled in by Jupiter's powerful gravity. This material would eventually rain down onto both planets, creating what could be described as the greatest snowfall ever witnessed in the solar system. The moons of both Jupiter and Saturn would also be affected. Some would collide with their own planets, while others would be flung into deep space. Some satellites might even switch owners, becoming trapped in new orbits. Others would lose any gravitational bond altogether. Weakened, Saturn would no longer be able to hold onto its more distant moons, which would begin orbiting the Sun freely. Now, let's imagine a second scenario. This time, Saturn doesn't just pass nearby, it collides with Jupiter at a relatively low speed. At first, the chaos would resemble the previous scenario: violent storms, atmospheric loss, and moons being hurled in every direction. As the distance between the planets shrinks, Jupiter begins to draw Saturn in even more aggressively. The closer Saturn gets, the more intense this absorption becomes. Over time, Saturn would be reduced to a shadow of its former self, slowly sinking into Jupiter's turbulent depths. The energy released during this process would create an intense glow, visible even from Earth. Incredibly fast winds would sweep across the surface of the gas giant. Atmospheric waves hundreds of kilometers high would form, completely mixing the matter of both planets. As time passes, Jupiter's familiar colorful bands would disappear. The planet would take on a more uniform, reddish, and opaque appearance. Deep inside Jupiter, Saturn's core would finally collide with Jupiter's core, releasing a colossal amount of energy. The two cores, both far larger and denser than Earth, would merge into a single structure. Saturn would cease to exist as an independent planet. Jupiter, now more massive, would have roughly a third more mass than before the collision. Its chemical composition would also be altered. After thousands of years, the storms would begin to slowly subside, and the planet would enter a long cooling process. Millions of years later, there would be no visible evidence that Saturn had ever existed. But now, imagine the worst possible scenario. Saturn collides with Jupiter at extremely high speed and at a disastrous angle. In this case, Jupiter would have no time to absorb Saturn's atmosphere. The two planets would collide almost intact. The impact would trigger extreme combustion, turning their atmospheres into a true ocean of fire. Jupiter's interior would be violently shaken. When Saturn's core strikes Jupiter's core, the energy released would be so immense that Jupiter itself would be torn apart. From Earth's perspective, we would see a sudden, star-like flash of light only for it to vanish moments later. The planet's fragments would be hurled into space, temporarily forming a new asteroid belt. These fragments would range from small debris to bodies the size of Mars. For some time, constant collisions would occur within this new belt. All the planets in the solar system would face real risks of secondary impacts. Chaos would spread across millions of kilometers. Over time, the larger fragments could stabilize into orbits around the Sun. Some might even give rise to new planets. However, none of them would have enough mass to replace Jupiter or Saturn. The solar system would never be the same again. This event would completely redefine the gravitational balance we know today. It would be the end of one era and the beginning of something entirely new. And so, we conclude this journey through one of the most extreme scenarios the universe could offer us. A collision between gas giants is not just destruction, it is transformation on a cosmic scale. These events remind us of how small and fragile our place in the universe truly is, and at the same time, how fascinating the chaotic dance of the forces that govern everything can be. Now I want to hear from you, which of these scenarios impressed you the most? Do you think the solar system could survive something like this? Leave your comment below. Your thoughts are essential for us to keep exploring these mysteries together. If you enjoyed this content, subscribe to Cloaked Mysteries, leave a like, and share it with those who also love the unknown. I'm Orthodox, and I'll see you soon, where the impossible meets the hidden.